Hi. I have a comment for Jonathan. I don't have, I'm here. I didn't have time to ask this before, but I just wanted to tell you that I'm not alone, you're not alone in thinking that there are diazotrophs in cold water. And we just published a couple of years ago a paper where we looked at the CPR data and we found trichodesmium, 50 years worth of data. We found trichodesmium in temperate waters all the way up to Iceland and down to 2 degrees Celsius. So whether they're fixing or not, we can't tell because we only have the samples, but they're there. So I really enjoyed your talk. I just wanted to let you know that you can expand the map of diazotrophs that Lou et al. did.
We're aware of that, but the observations for fixing nitrogen have not. When they've been detected and rates have been measured, they weren't fixing nitrogen. But there's not that many studies. So.
Yeah, but that doesn't mean that we can't find them in the future.
Yeah, exactly.
Thank you. I have a question for Mattel and maybe for you too, John, about the types of the phytoplankton community that is seeding these big blooms in the Arctic. The in-ice phytoplankton versus those that are free in the water column. My understanding is that, and you tell me if I'm wrong, that it's not the ice algae community that's seeding the blooms, that it's the phytoplankton that are in the water. And I was also thinking about the origin of some of your cells, John, and whether you know whether those are in the ice community or not, or if anybody has looked. So I was wondering if you could both comment on that, what is forming these, how are they seeded?
From the question to know if it's coming from sea ice algae, you have a lot of studies now, especially from the Canadian cruises, for example, doing some overwintering in the Beaufort Sea. There's two types also of bloom, mostly linked to diatoms, and some are linked to penase diatoms. And for this type of undersea ice bloom, it seems to be linked to sea ice algae. But if it's linked to centric diatoms, they expect that it's maybe more linked to local growth in the water column. So I think we don't have one answer to explain the origin of this undersea ice bloom, because it's depending of the sea ice dynamics. For example, if we have there's so that, for example, during the escape, the sea ice camp during Resolute, that some events of rain just push all the sea ice algae in the water column. And for this scenario, it was sea ice algae and penate diatoms initiating this bloom under the sea ice. But when we have like a slow transition of the sea ice dynamics, it seems to favor more centric diatoms and not penate diatoms. So depending the situation, we may have different origin, I think. And now we have perhaps also photosynthesis blooms, which need to take into account.
Yeah. You haven't looked in the ice yet, I figured.
I mean, we do have some samples that are meltwater that might ultimately give some indication, but we haven't really done that experiment. I mean, we're kind of 2 years into this now, but we weren't prepared for this. We weren't really expecting this.
Hi, John. Great talk. I was curious if there's any thought about possibly the haptophyte host also being maybe mixotrophic, because you see a response even if you add nitrate, which might stimulate the overall productivity in your bottles. That I don't know how. It's obviously not taking an N.
I'll try to keep this to a 30-second answer. So there is some evidence that it's mixotrophic. It was caught in a SIP study, not to be punny, but in Penny Chisholm's lab that they found some Broruta sphaera when they were doing a grazing experiment by tracing a stable isotope. But beyond that, we don't know. Kendra's actually done some fluorescent bacteria studies, and we get a little activity. So there is a fairly good chance. Yeah, there's some things I don't want to talk about because I know from workers in Japan and what they are finding out. I mean, where the symbiont lives might actually be related to where they feed. So I'm not quite sure how that'll interact. And I'll just use this to mention that there was this paper recently that claimed that Broruta sphaera was eating Prochlorococcus through a special type of digestion, extracellular digestion called homocytosis. Read my blog and tweets about that. That's not. Read the comments on the PLOS biology website about that. But that's not evidence for. Yeah.
Thanks. I'm over here. Thanks for an interesting session. We had such a broad diversity of topics. I wanted to follow on Debbie's question about this seeding of sea ice, seeding of water column blooms from the sea ice. And I'm wondering if that change in this what you described as the borealization of the annual cycle, do you anticipate that might change how those blooms start the next season? So does what happens in that summertime influence then whether the seeding comes from the water column, the sediment, or the ice? Does that change? Do you have any predictions on that?
I think, yeah, this is a very important question to look at now because it seems the articulation is quite stratified. We don't have during winter the reset of all the water column. So everything that will happen during summer or fall or the fall period will have an impact on the first the polar night, because more and more papers are showing now that we can see high biological activity on the sea ice via heterotrophic activities, but also grazing, also from the zooplankton. And for sure, it will impact what is happening on the sea ice. For example, the occurrence of undersea ice bloom or not. So it will change all the biogeochemistry, I think, on the sea ice. So we need to link both what is happening in fall, how it will impact the biogeochemistry, and trying to look more carefully at what will happen after that. Yeah.
Hi, I have an Argo-related question. I can envision when planning a cruise, particularly to sample the water column, it would be really helpful to have access in real time to Argo data for Argos that are in the area to get a better appreciation of internal waves and stratification. It would really help rather than budgeting for separate Argo surveys just before a cruise, for instance. So is that possible? I think I kind of feel like I should know the answer to that, but I don't.
Yes, all the Argo data is made available in real time. There's it's called the GDAC, Global Data Assembly Center, and then people take data from that and also make additional products. But in general, when an Argo float reports its data, it becomes available to the public within about 24 hours. It's a little hard to find exactly where you're looking. They do have some tools at various websites where you can select a geographic range and extract the data.
And is this through the Argo website or?
Well, there's several Argo websites. There's the Argo Information Center, the AIC. They have some tools for extracting real-time data. There's also the Argo GDAC, which Global Data Assembly Center, which contains all the data. They don't have quite as a friendly front end to pull it out. But, and then there's an additional, like the main Argo page, which is out of UCSD. In their sidebar, they have many links to various data formats that you can download.
Well, thank you.
I have a question, I think mostly for Mathieu, but others may be able to, I was thinking maybe Lauren may have some input on this. So you showed in one slide the silica stress that's happening at the one end of the Arctic. Could you kind of expand on that a little bit? And specifically, I was also kind of wondering if in some regions on the West Coast, right, they talk about that potentially being a precursor to some harmful algae, right, promoting harmful algal growth. You can't hear me?
No. Sorry.
So on one of the slides, you showed that there was silica stress. You found some evidence for silica limitation, right, in your nutrient data. I was wondering if you could expand on that a little bit, like ideas for why that might be, and then sort of within the context of the question, like on the West Coast, there's certain regions that have suggested that limitation could promote growth of certain types of harmful algae. I was wondering if anyone's thinking about that in the Arctic as well.
This is relatively new, that we saw with the silicate limitation, and there were some papers seeing this decrease in silicate in the Arctic Ocean. And few hypotheses was the first that it may be linked to a biological response. It was linked to, sorry, it was linked to a biological production, mostly in the buffer gyre. So perhaps you may have perhaps more diatoms activity, decreasing the silicate, but this is one hypothesis. The second one would be also to a longer retention of the water in the buffer gyre due to the intensification of the atmospheric coupling and with the atmosphere-ocean coupling. And what we saw here, I was thinking that it was probably linked to large-scale transport from the Pacific side of the Arctic Ocean, and through this pathway we may see a loss in silicate. But for example, the ice is in Atlantic waters. So this is not following the hypothesis that it may be linked to this Pacific water. So for the moment, we don't have a clear idea if it's linked to biological responses or physical, because the third one may be linked also to the change in the water masses and the currents in the Arctic, which may impact directly the different ratio of the water masses. So we still need to find which one may be the best scenario to explain that.
Okay. My question is for Lauren. I know that some trace metals are enriched in the transpolar drift, like uranium. Sorry. What I don't recall is whether there are any macronutrient enrichments or even macronutrient ratios that would be indicative of shelf origin. Have you looked at that?
We've looked at, we compared silica between 2015 and 2007, and it was, so it's not a ratio, but that's what I've looked at so far. And it was higher, but we ultimately didn't end up showing that just because silica, like Matthew was just saying, can be affected by biological or physical mechanisms. I think it's going to be hard to tease apart the contribution of nutrients and metals from rivers and shelf inputs, because the rivers are discharging onto the shelf, and then that's being carried in the transpolar drift out to the central Arctic. So I know there's been iron enrichment has been shown in the transpolar drift, but I think the current thought is that that's coming from rivers, and so we might not see changes in that due to shelf inputs. And so I think that's something we need to look at in the future, is what we're going to be able to use to identify that distinct shelf input, which I think is probably the point you're making.
I also had a question about the silica concentrations, and I guess I was wondering how low are those silica concentrations, or is it really just the ratio that's driving that, or is the silica concentration actually really low?
I think it's both, because what I shown here was the winter nutrients concentration and ratio. But for example, in the NICE programs, value was around 5 micromoles of silicates. So still very low, but normally still enough to get some diatoms, I think.
Oh, you're not.
Any other questions or thoughts? Anyone wants to go to lunch?
I want to thank all our speakers one more time.
Thank you all for a great two poster sessions, and I want to remind you that the poster sessions can continue if you put your poster on the poster gallery that's online. They're really nice, high-resolution images you can blow up and talk with your colleagues at coffee breaks and share those, so definitely keep that in there. It's also a really nice archive.